Hello, good evening. So let's solve some more problems. And before we start with our today's session, just let me give you a small correction about the last video. In the last session regarding this problem, so everything was fine except this part. This 1 over 4, I somehow, by mistake, I wrote here half. So this would be simply 1 over 4. And then uh, the 1 over 4. So this will turn out to be uh, 3 basically. So the answer here would be 3n. Let's go ahead. So let's take the 16th problem of this series. So we have this equation, and this equation has no real roots. And then it is given that f of x is equal to square root of log of this entire expression is given here. So now for the log, we already know that this in the square root part, log of this should be what? Positive. That means I'll be having here log of pi plus e, and then there's a square root portion, ax4 plus 7a minus 2b into x cubed plus 12a minus 14b minus c into x square minus 24b plus 7c into x plus 1 minus 12c. This should be positive. So when I'm saying this should be positive, which implies this quantity, okay, the entire quantity, this would be taken as this 1 0. I'll be writing log 1 to the base pi plus e. So this entire thing, I'll call it some, say, g of x better. So that means now I'm saying that log of pi plus e, and then this g of x should be more than 0. I can write down log 1 to the base pi plus e. So in this case, pi plus e is more than 1, so inequality remains unchanged. So g of x should be more than 1. Now g of x is basically, we have here ax power 4 plus 7a minus 2b into x cubed plus 12a minus 14b minus c into x square minus 24b plus 7c into x plus 1 minus 12c is more than 1. So in this case, this 1 and 1 is gone. So now all I get to see is just ax power 4 plus 7a minus 2b into x cubed plus 12a minus 14b minus c into x square minus this quantity, that is 24b plus 7c into x minus 12c should be more than 0. So this quantity we have to solve for log. And of course, when we are saying that this thing is always positive, so when this is always positive, now what we can do is, they already have said that this equation has no real roots. So this quantity I can shift here 1 and then write down this quantity is always more than 0. So now it is enough to solve this entire equation. So instead of solving this one for x power 4, okay, it's better to try to factorize this. So in this case, I'll be collecting all a. So this is x power 4 and plus 7a x cube, and then here this will be 12x square. I've collected all a. Now let's collect b. So b will give me here, it is minus 2 and then x cube. And here I have minus 14 x square. And this will give me minus 24x. I've collected b now. So the next target is to collect c. So c will come with minus x square here. And then minus 7x here. And then minus 12. This is more than 0. Now all we have is, here we can collect ax square common total. So this would give me, oh, this is not 7ax cube, this is just 7x cube. Already we have taken a outside. So we end up getting ax square here. This will be x square plus 7x plus 12 here. And then minus 2 I'll be taking common. So this gives me again x square plus 7x minus, no, plus 12. And then here I can collect minus c. So this gives me x square plus 7x plus 12. is more than 0. So now we can collect this entire thing. So we have ax square minus 2b and then minus c. This into, so the next part will now become x square plus 7x plus 12. This quantity we are saying more than 0. So of course these both are quadratic and we are saying that this is more than 0. So if I treat this one separately and this one separately, so it is enough to say that either both of them are positive or both of them are negative. So now the only thing will be, look, we need the domain of this function. So for the domain of this function, of course, my quantity a should be positive. So a should be positive, and then SGN of negative SGN of 1 plus c plus 1 plus ac plus b square. So if I go and control this thing, so I need this quantity is appearing in the square root. So for this part, I should be having minus of SGN of 1 plus AC plus B square. 1 plus AC plus B square. This also should be greater than 0. So which means SGN of 1 plus AC plus B square should be negative. So this is one. Now let's go ahead and find out this thing. So if I have ax square minus 2b minus c, let's calculate the b square minus 4ac there, because both of them should be positive or both of them should be negative. So let's control this guy first. So we'll get to know, because our a is positive. Looking at this thing, we say that a is positive. So if a is positive, that means graph is going to be upward. So this quantity cannot be negative. So this quantity should be more than 0. So if this is more than 0, then this also should be more than 0. Because this quantity, we are saying that this is completely negative. So for that, a should be negative. But that's not true here, because we need a to be positive. So it is enough to say that x square plus 7x plus 12 is positive. So x square plus 7x plus 12 should be positive, which means I have here x plus 3 into x plus 4 is positive. That means x belongs to minus infinity to minus 4 union minus 3 to infinity. So the domain of f would be minus infinity to minus 4 union minus 3 to infinity. This would be the domain of. Now let's go ahead for the next problem. We have another guy in the town. Let's go for this. So we have f of x is given to be 4x cube. F of x is 4x cube minus x square minus 2x plus 1. And g of x is given to the minimum of this function between 0 to 1. So basically, I need the behavior of this f of x in this interval. So we have to see the minimum of this function. Okay, the point where does the minimum occurs, whether it lies in this domain. If it is lying in this domain, then we will go ahead. If it is not lying, then we directly have the minimum function itself here. So let's go and find out. So f dash of x will be 12 x square minus 2x minus 2. So we can take 2 common. This gives me 6x square minus x minus 1. So you can factor this out. This will be 6x square plus 2x minus 3x and minus 1 will give me 2 times. This would be 2x into 3x plus 1 minus 1 into 3x plus 1 will give me 2 times 2x minus 1 into 3x plus 1. So this is my f dash of x. So if you see here, then this is minus 1 over 3 and this is half. So we see here that the slope is changing from negative to positive. That means half is a point of. So x is equal to half is a point of minimum. So you can see by the change of the slope. So slope is changing from negative to positive. That means a point of minimum. So this is a point of minimum. That means we now have to sketch this graph. And of course, this is plus to minus. So this is a point of max. Point of maxima. So now we will see the graph of this function. So if we see it carefully, so we also have to find out the minimum value. So f of half we will find out. So f of half will be 4 into half cube is 1 over 8 minus 1 over 4 minus 1 and then plus 1. So this both of them cancel each other, and this is 4, 2. So this gives me 1 over 4. So f of half is 1 over 4. That means the minimum value is 1 over 4. This is the minimum value. So if we understand the meaning of this function, this says that you have to keep taking the minimum of this function. Okay. So once, if I try to draw, then since we have to talk only about 0 to 1. So I'll be graphing only between 0 to 1. So at 0, I'll find out the value. So this turns out to be 1. At 0, this is 1. And then this is 0. This is 1 right here. And then here will be somewhere 2. This is half in between. So at half, we have the minimum, and the value is 1 by 4 here. So that means this function should go like this, because this has maximum at minus 1 by 3. So that means the graph is actually decreasing from here, because minus half to 1 over minus 1 over 3 to half, the function is decreasing here. So that means at 0, the function would be achieving 1, and then this would start like this. So we have to keep taking the minimum. So up to 0 to half, the minimum value, the minimum of f of t is going to be the function itself. But the moment I reach half, this function will take the value 1 by 4. It will continue up to 1. Because we have to keep taking the minimum. Once this part is done, now we have here 3 minus x. So at, of course, this function is broken here. So now we have 3 minus x, that means y equal to x, and then shifted 3 units up. So yeah, we can just plug in x is equal to 1 to get 2. So that means at 1, I'm having 2 there. So this will go here somewhere. And at 2, you can just plug in, so you get here 1. So this line would be like this. So this is the graph of this function, g of x. Now, once we have found this thing, even this was not required, we can sketch this properly like this. That g of x is equal to the function itself between 0 to half, and then half to 1, I'm going to get the constant line, that is 1 by 4. And then from 1 to 2, what is given? To 2, we have the second function that was given to be, I think, 3 minus x here. So 3 minus x here. And then here we have the function itself between 0 to half. So that is 4x cubed minus x square. 4x cubed minus x square. And then minus 2x plus 1. So minus 2x plus 1. So now we need the value of g of 1 by 4, 3 by 4, 5 by 4. So g of 1 by 4 plus g of 3 by 4 plus g of 5 over 4 will be equal to, now we want g of 1 over 4. 1 over 4 will be governed by this interval. So we'll find out here g of 1 by 4. So this will give me 4 times 1 over 4 cube, which is 64, minus 1 over 4 square is 1 by 16. And then minus 2 by 4 is half, and then plus 1. So this is my g of 1 by 4. So 4 and 16. Oh, wow. Celebration begins. 1 minus half will be half here. So g of 1 by 4 is half. And then g of 3 by 4 will be given by this equation, because this is 0.5 and 3 over 4 is 0.75. So g of 3 by 4 is going to be 1 by 4 itself. And g of 5 by 4 will be given by this equation, because 5 by 4 is more than 1. So yes, so 3 minus 5 over 4. So that gives me 12 minus 5 is 7 over 4. So if I add all of these, I'll be having here half, plus this is 7 plus 1, 8 over 4 will give me 2. So this gives me 5 over 2. So but the question is asking us to find out 2 times. So the answer would be simply 5. Let's go for the next one. We now have a matrix, 3 cross 3 matrix, and the value of x for which A is symmetric. That value is taken to be alpha, and then we have to design one more equation f of t by using this alpha. And then it is asking us to find out the number of integral values of lambda for which f of t is equal to lambda has exactly 4 solutions. So the highlights are clear. Now we need the matrix A to be symmetric. So I want A should be equal to the A transpose. So if A is equal to A transpose, which means this value must be equal to this value, and this value must be equal to this. So let's go ahead. So I'll consider this value. That is nothing but x cubed minus x plus x square minus 1 must be equal to x minus 1. So if we see here, then 1 plus 1 is 2, and minus 1 minus 1 is minus 2. So 2 minus 2 is 0, which means x minus 1 is one of the factor here definitely. So that means we can factor this out. So this gives me, I can keep x common here. So this gives me x square minus 1. And again, we can keep 1. And this is x square minus 1 is equal to x minus 1. So I can now keep x square minus 1 here. And then I have x plus 1. And this is equal to x minus 1. So this will give me x minus 1 into x plus 1 square is equal to x minus 1. So x minus 1 gets cancelled from both sides, which means x is equal to 1 is a factor. Oh, sorry, solution to factor. X minus 1 is a factor because that got cancelled. Or the actual stage would be to take x minus 1 to that side and then take it common, then apply the basic algebraic laws. So x is equal to 1 is one of the solution, and that's the only solution. No, that's not the only solution. Okay, we have something else in the bucket. So we have x plus 1, and this gives me x plus 1 square is equal to 1, which means x plus 1 is equal to 1 or minus 1. This means x is equal to 0 or x is equal to uh, x is equal to 0 or x is equal to minus 2. So we have these many values. So now if I consider this thing, that means I want both these entries must be same because A is equal to A transpose. That means A32 must be equal to A23. So if these two are equal, then we have to see for which value both of them are equal. Because the same value I have to see here also. So here, because this should be symmetric for the same value of x, not for some other values, because the same x I'll be plugging here, here, at all of the places. And since diagonal remains invariant, so we don't have to be concerned about the diagonal because matrix is symmetric. We want the matrix to be symmetric, and A is equal to A transpose won't affect the diagonal. Diagonal remains intact. So let's go. We have 1, 0, and minus 2. So if I plug in 0 here, I'm getting minus 1. So add 0, we get minus 1. So that means both of them are equal because we have solved this thing, of course. And when I plug in here 1, of course, they both are 0. So again, fine. When I plug in minus 2, this gives me minus 3 here, and this gives me, yeah, we need to see here this one also. But if I see x is equal to 0, this is making this one 0, but this one not. That means x is equal to 0 is ruled out. And for minus 2, we can see here, this is giving me minus 2 square is 4 into 5 is minus 20, and then minus 10. So this is giving me minus 20, and minus 10 is minus 30. So this is also giving me minus 30, then x is equal to minus 2 will be locked, or else x is equal to 1 we have to see. Or rather we test at x is equal to 1 because I find this one to be a bit simple. So minus 5 plus 5 will give me 0 here, and 1 is making this one 0, this one 0, okay. And this one is 1 plus 1, 2 plus 4, 6, minus 6 is 0. Yes. So this implies x is equal to 1 is the only value for which this matrix is going to be symmetric. That means my alpha is 1. Because we wanted the value of x for which a is symmetric be alpha. So alpha is 1. Now we have another equation which is f of t is equal to modulus of modulus of modulus of. So t minus 2 minus 1 minus 3 the whole minus 1. So this is my f of t, and f of t is equal to lambda. That means we need to graph this polynomial, this modular expression. So we have f of t is equal to, rather take it to the next page. So f of t is equal to mod of, this is t213, okay. So mod of t minus 2 minus 1 minus 3, the whole minus 1 I have here. So let's go ahead. Now I need to plot this to see the graph. So I'll find out all the critical points here. So one of the point is t minus 2 is equal to 0. That means t is equal to 2. And then we have the nested modulus t minus 2 minus 1. Okay, this must be 0, which means mod of t minus 2 is equal to 1, which means t minus 2 is equal to 1 comma minus 1. Means t is equal to 3 and 2 minus 1 is 1. So t is equal to 3 and 1. And then the third nested modulus is mod of t minus 2 minus 1. This mod minus 3 should be 0. So which means I have here mod of t minus 2 minus 1 is equal to 3. That means mod of t minus 2 is equal to 4. No, this is mod is 3. That means this is going to be 3 or minus 3 both. So if I take mod of this is equal to 4 and 1 minus 3 is minus 2. So mod can never be negative. So this is discarded and I have mod of t minus 2 equal to 4. So mod of t minus 2 is equal to 4, which means t minus 2 is equal to 4 comma minus 4. That means t is equal to 6 or minus 2. So we have all the critical points noted. We'll now plot it here. So let's plot all of them. So the most negative is minus 2 here. Let's keep minus 2 here. And then we have 1 also, 2 also, 3 also. So we have to go in the sequence. That means 1, 2, and then 3. Next in the line will be 4. My goodness. Okay, we'll go for the next page a bit. This is insane. So now if I plot all these expressions, so I'm going to have it here. Let's plot it here. This is minus 3. Minus 3 is not even there. Minus 2 is there. And then we have 1, and then 2, and then 3, and 4, and 6. All these are the points. Now I'll find out the values at those points and just join join all those critical points. That will give me the graph of this expression. So at minus 2, I see minus 2 is the root of this interval. So if I plug in here minus 2, I'm going to get here 4. Minus 2 is 4, minus 1 is 3, minus 3, entire thing is 0. So at minus 2, I'm getting minus 1. So this value is minus 1. I'll just plot it somewhere here. So this value is minus 1. At minus 2, I'm getting minus 1. At 1, we get here 1 minus 2 is 1, minus 1, 0. And mod of 3 is 3 minus 1, which is 2. So at 1, I'm getting 2. At 1, I'm getting 2. At 2, see what do we get? So 2 minus 2 will be 0. 1 minus 3 will be, this is 1 minus 3 is minus 2. And then 2 minus 1 is 1. So at 2, I'm getting 1. So at 2, I'm getting 1. At 3, let's see. So plug in here 3 minus 2, 1. Minus 1 is 0. Minus 3 is 3. Minus 1 is again 2. So this would go to this side. And then 4, I'm having 4 is a solution for the nested one. That means 4 minus 2 is 2. Minus 1 is 1. Minus 3 is 1. Minus 3 is minus 2. Mod 2, again, I get here 1. At 6, let us see. So 6 minus 2 is 4. Minus 1, 3. Minus 3 is 0. And then minus 1. So at 6, again, I get minus 1. So the graph would go somewhat like this. Here it will come like this, and then again join this one here, and then again here, and again here, and then again here, then again here, and then this would go here. So now we want f of t is equal to some lambda. So if I want f of t is equal to lambda, which means we want exactly 4 solutions. So lambda is like a constant value, so it's a parallel line to x. So I want 4 solutions. That means my line should intersect the graph 4 times. So if I start anywhere between minus 1 to this interval, if you see minus 1 to 1, if I see any line, then I'm going to have here 4 solutions. Is minus 1 counted there? So can we take 1 there? Because at 1 this will be touching here, and then here 1, here 1, here 1. This value at 4 I'm having 1 only, no? 4 minus 2 is 2 minus 1, 1 minus 3 is 2 minus 1, 1. Yes. So again, I'm get this line would touch here. So 1 I cannot include because for 1 I'm getting 1, 2, 3, 4, and 5 solution. That means 1 is not included. So anywhere between minus 1 to 1, I can draw a line like this. This is my lambda. So you see here 1, 2, 3, and 4 intersections we are having. Anywhere between minus 1 to 1. That means my lambda belongs to what? Minus 1 comma 1. So if I take any lambda between minus 1 to 1, I'm going to have here f of t is equal to alpha will have 4 solutions. And now we want the integral values of lambda. So that means I'm going to have only 1. Between minus 1 to 1, there is only one integer, which is 0. So the answer would be 1. Let's go for the next problem. So let's go ahead. So now we have 1 to 2026, x minus maximum of p belong to integers, so that p is less than or equal to x. So this is nothing but the definition of greatest integer less than or equal to x. So I can write on x minus GIF of x over x dx. Because GIF of x is nothing but what? The greatest integer less than or equal to x. So this is just another way of writing. So now we'll go from here 1 to 2026, and then x over x gets cancelled. We get minus x, GIF of x over x dx. So in this regard, we are going to have here 2026 minus 1, which is 2025 directly. Then minus integral 1 to 2026 GIF of x over x dx. So for this, I'll just consider this equation to be star, and I'll consider only this part. There is no point in writing 2025 like this. So consider this, I'll call this expression, say I1. So I1 is equal to what? I'll consider 1 to 2026 GIF of x over x dx. So since 1 to 2026, I now have to partition. So 1 to 2026 GIF of x over x dx will now be written as 1 to 2, and then 2 to 3, then 3 to 4, and so on up to 2025 to 2026. So GIF of x over x, then here also GIF of x over x plus GIF of x over x, and so on up to this one also GIF of x over x dx. This could be written as nothing but summation n is equal to 1 to 2026 basically. And then, no, 2025. Because we are starting from 1, so my integration will be from n to n plus 1. And then this is nothing but GIF of x over x dx. So which means this summation would be n is equal to 1 to 2025, n to n plus 1, GIF of x is simply n over x dx. That means my n will be outside, and then I get sigma n is equal to 1 to 2025, 1 over x dx. And then this would be simply, wait a minute. n is equal to 1 to 125, n to n plus 1. This is the same thing, right? 1 to 2, and then 2 to 3, 3 to 4. Okay. So n is equal to 1 to 225, n to n plus 1, GIF of x is n. So now this integration would be n times, and then this is ln x, basically. So sigma n is equal to 1 to 2025. It will be still like this only, because though I have written n to n plus 1, the matter is not yet over. Yeah, I'll remove this, because the integration part is not yet taken. So let's remove this. Then this is from n to n plus 1. So n is equal to 1 to 2025. This part will give me sigma n is equal to 1 to 2025. This n would be outside, and then ln of x. And integration goes from n to n plus 1, and then dx. Now I'll extend this matter further and write down here. This n would be outside, and then this is ln of n plus 1 minus n with summation. N is equal to 1 to 2025 n into, this is ln of n plus 1, ln of n plus 1 minus ln of n. So now we need to find out the summation. So the summation is sigma n is equal to 1 to 2025 n into ln of n plus 1 minus n into ln of n. This is what I have from here. I'll multiply this. Now we can bring it to a telescope. So I'll be having sigma n is equal to 1 to 2025. This n I can write down n plus 1 into ln of n plus 1 minus n into ln of n Keep this one here, and then since we have added here 1, so I'll subtract minus of ln of n plus 1. Then extend this series again further. So n is equal to 1 to 2025 at this. Now let's go ahead. So this will be telescope basically. And here if you see, then this is n is equal to 1. So I get here 2 ln2 minus 1 ln1. And then similarly, next one will be 3 ln3 minus 2 ln2. And then plus 4 ln4 minus 3 ln3. And last one will be 2026 ln 2026 minus 2025 ln 2025. And you see this is a telescope, so all these guys would go away and we are left with only 2026 ln 2026. And regarding this part, this is nothing but ln summation. So ln summation would be, if I plug in here, then I get here ln of 2 plus ln of 3 and so on up to ln of 2025, which I can write down minus of ln a plus b property that will give me ln of 2 into 3 into 4 and so on up to 2025, which is nothing but minus ln of 2025 factorial. So the final answer will be given as 2026 here. I'll write down this thing is equal to 2026 into ln of 2026 minus ln of 2025 factorial minus ln of 2025 factorial. Now again we can use the property, so I'll be having ln of 2026 power 2026 upon 2025 factorial. Now this value I'll just keep it here. So we the final answer would be given by this thing is equal to this 2025 I'll write down, and then this entire thing we have found to be minus of where is it? No, not on this page. Right. Oh, here. So this entire portion we have found is 2026 ln 2026 minus ln of 2025 factorial, which is this basically. So I'll just keep it here. So this part will give me minus ln of 2026 power 2026 upon 2025 factorial on 2025 factorial. So that's the answer to this problem. So that's all for today. We'll see you in the next session. Happy learning. Bye bye.